Hello, everybody. I had a bit of an introduction earlier, and someone spoiled my talk already, so this should be really quick. Before we get into that, though, how many here are Prometheus users? Hands up. Wow, okay, great. How many are running on Kubernetes? Okay, a bunch of you. So the talk's mainly going to focus on Prometheus on Kubernetes for all the examples, but hopefully the ideas are generic enough that they can be deployed anywhere. So you've heard all about me already. I'm going to skip that bit. Talk's in 4 sections. If we're really lucky, I'm going to get to all 4 of them. But I've only got 20 minutes, so I'm going to give a whistle-stop tour. Firstly, the introduction. Why am I giving this talk? So Prometheus has its own conference, a bit like Grafana Con, called PromCon. At the most recent one, all the speakers were mentioning this thing called the red method. And I was like, hey, I recognize that. No one really explained what they meant by the red method. So I thought it was my duty to come and explain to people what the red method means. I'm going to skip a whole bunch of the other debates around Prometheus. I'm not really here with, today at least, representing Prometheus. It's more of a general talk. So I'm going to skip the whole push versus pull debate. We can have that tomorrow. I'm going to skip the whole white box versus black box monitoring debate. So first, though, before we talk about the red method, I'm going to talk about the use method. So this was already mentioned, and the chap before rightly said it's utilization, saturation, and error rate. This was done by a chap called Brendan Gregg. He is the expert on this, and this website he has built is absolutely fantastic. So I'm really only scratching the surface of the level of detail that he's put into it, and I really encourage everyone to go to the source of the information. He gives definitions for what is utilization, the percent of time a resource is busy, the amount of work a resource has to do, and the count of errors. So these are really useful, but they're a bit abstract. But before I get into kind of making them a lot more complete, I'm going to talk about why we have the use method at all. Right, so who's ever been in a situation where something is broken, like users are complaining, and I don't really know what's wrong? Right, and so you all have your checklists that you go and sit through and you go, right, I'm going to check this first, I'm going to check this first, I'm going to check this first. And eventually you run out of your checklist and you're like, I don't know what's wrong. So the use method is a way of building that checklist that covers everything, right, by definition. So you take every single resource and you check these 3 things. So you have a checklist. This turns kind of intractable problems into tractable problems and helps you know about the unknowns, right, know what you don't know, basically. So, what would we do for, say, CPU utilization? These are Prometheus. I'm not going to walk through these, though, because half of you already know what they mean. Prometheus has an exporter called the node exporter. It's a little job you run on every host. In Kubernetes, you'd run it as a daemon set, and it exports counters for all the CPUs in your system and all the time they've spent in all the different states. And so with this really simple one-liner, you can turn that into a utilization metric. Saturation. That's actually really easy in Linux, because you've got this thing called a load average, right? The length of the run queues, or the average length of the run queues. And so I like to normalize my saturation metrics by 100%, by the number of CPUs. So I know this is starting to move away from what top does, for instance. But this means I don't have to remember how many CPUs I have in any given host. I can just go 100% is bad, or more than 100% is terrible, less than 100% is fine. Oh, you'll notice I didn't have errors on here. Who knows how to get CPU errors? Or what even is a CPU error, right? Some suggestions from Brendan Gregg's website are things like machine check exceptions. And the machine check exceptions, there's no counter for that in Sysfus or Procfus. I guess you could grep through dmessage, use something like mtail to grep through dmessage and export a counter of those. But the reality is, on a cloud system, if you're running on Amazon, you don't see them in your dmessage. If you did get a machine check exception, your VM probably disappears. I'm going out on a limb there. Similarly, memory utilization gets a bit more tricky because, what is memory utilization? Do you count caches towards utilization? Traditionally you don't. Docker, when it first exposed Prometheus metrics, I think it's Docker, it might have been CAdvisor, was counting caches toward utilization. So you get a wildly different answer if you asked it what the memory utilization was versus something like top. So you've got this query. All these queries are in GitHub. I'll give you a quote later. And then saturation. Saturation of memory is kind of a weird one. Brendan suggests you look at paging in and paging out and the rate at which you're doing that. His idea being that a high rate of paging indicates oversaturation of memory. And you'll notice this one isn't normalized to 100% either. So this one kind of sucks. And again, no errors. What is a memory error? And how do you count them in Linux? I guess it would be really nice to have some like counters from the CPUs and things, counting like how many times they've corrected EEC bits and stuff like that. But yeah, c'est la vie. And the list goes on. Like there's literally every single resource you can do this, and then you get the resources that everyone always forgets about, things like interconnects. Network utilization is another interesting one because, you know, to know your network utilization in the normalized way that I like to do it, I need to know how much traffic my network can support, which is actually quite hard to get out of a Linux system. So we have like a little table that says if it's this kind of instance, it should be able to achieve this, and now we can say what our network utilization. Saturation with network's easy though. Anyway, quick demo. I'm going to, as I said, I've made all of these queries available on GitHub, and of course I needed a name for this project, because every good project needs a name. How else are you going to get GitHub stars? So we came up with a name, David and I, well, I say David and I, David rolled his eyes when I came up with this name. It's called Clumps, so it means Kubernetes Linux use method with Prometheus. Please don't clap that. It's a terrible name, and it's not working either. But anyway, this is the dashboards. As you can see, I've only got utilization and saturation. It's really hard to get error rates. We're looking at disks are actually something at least Linux explodes a counter for, so we're looking at plumbing that through the node exporter, but right now it's not even plumbed through the node exporter. But we've got, you know, the 4 common resources here, and one of the things David has just literally added and pushed, like the hour before this talk, is drill down. So I can now click on these links, and it takes me to a different dashboard that won't load because of the Wi-Fi. But it actually works. Apparently, what issue number is this? Apparently this is like a long issue on the Grafana GitHub, and we'll obviously be making a PR for this so that everyone can have this wonderful, wonderful thing. And how now do I just show one host in that view? Because I used to just click the label. Okay, well, quickly gloss over that. So anyway, there's the use method dashboards using clumps, and it's on Causal's GitHub. I guess soon to be Grafana's GitHub. Oh, it's loaded, has it? Yeah. Yeah, it's loaded on my other screen. So that is clumps. I'm not giving a huge number of references because Brendan Gregg's website is so good at this. So Brendan Gregg's website, clumps, these are on my Twitter, on our SlideShare and so on, and these are all clickable links. The red method, now we get into the meat of the talk. So the story behind the red method is, as we said, we were sitting around, I was saying it to someone else, I think. We were sitting around at Weaveworks, and we'd hired a new guy, and he'd asked us what our monitoring philosophy was. And we kind of like, yes? And he said, well, there's this thing called the use method, and we should really use it. But previously, a few of us at Weaveworks spent some time at Google, and we knew that Google didn't monitor its services using the use method. The use method doesn't really apply to services, it applies to hardware, it applies to networks, disks, things like this. And we really wanted a microservices-oriented monitoring philosophy, for want of a better term. So we came up with the red method. And we knew it had to have, you know, it had to be a method, right? Otherwise it wouldn't fit. And we knew it had to be a 3-letter acronym. And that's how we arrived at rate, errors, and duration. And it seems to be really catchy. Who would have thought something as simple as this would be the thing I get known for, which is awful. So I looked at like the thing, the first talk that this was mentioned, and it was a talk at the London Microservices User Group in December 2015. So this is like 2 and a bit years old now. Everyone should understand really, like the error rate, the request rate, and then some distributions of latency for those requests. You model this for every single service in your architecture, and this gives you a nice, consistent view of how your architecture is behaving. Giving these kind of consistency across services really allows you to scale your kind of operational function, and really allows you to basically put people on call for code they didn't write, right? Which may not sound that particularly attractive, but I mean, I spent 2 years as an SRE at Google, and I didn't write any of the code I was on call for. And that wouldn't have been possible unless all the services had exposed red methods, basically. It also means, it means you don't have to always be on call for all the code you've written, which allows you to just scale your operational function. The other thing with the red method is it's very close to what customers, like it's a good proxy for how happy your customers will be. You know, if you've got a high error rate, that's basically going through to your users and they're getting page load errors. If you've got a high duration, your website is slow. So these are really good for building quite meaningful alerts around and for measuring your SLA, basically. So, yeah, and the final point that gets, every time I say this, someone in the audience will tweet it. It's like the red method is about caring about your users and how happy they are, and the use method is about caring about your machines and how happy they are. And I don't care how happy my machines are. In fact, if I can run my machines at 100% utilization whilst keeping my users happy, I'm happy, because that makes a very cost-effective service. Yeah, this is the time I think I first mentioned it. This kind of painted me in a bad light, mainly because of the hair, I think. But I wasn't proposing an alternative. It's kind of complementary. I mean, at Causal, we do both, right? We have use method for our resources, and we have rev method for our services. So it's not an alternative. Doing this in Prometheus, this is Go. Doing this in Prometheus is super easy. You declare the method. Does this point work? Yeah, look. You declare the metric. You register it with Prometheus. We've broken this histogram, and the reason we use a Prometheus histogram is because it also exposes a count of the number of requests and a sum of all the request durations, which is helpful later. So we also break this down by method, route, and status code. And the reason we break it down by status code is so we can count the error rate. The reason we break it down by route, is because in some cases you'll find your 99th, your error rate for all of your service is really low, but if you look at the error rate for one particular HTTP route on your service, it's 100%. And that HTTP route just gets called, 100 times less than the other one. A good example is queries versus writes. And at Causal, the writes come into our front end and, are easily like 3 orders of magnitude more QPS than the queries coming into our front end. And so if we didn't break this down by route, we would never know that our queries are failing, which has never happened, I promise. Then if you want to actually measure it, you take your HTTP handler in Go. Who's familiar with Go here? Oh, okay. Should have picked a different language, maybe. You take your HTTP handler in Go, we wrap it in a piece of middleware, and all this middleware does is run the handler, which is missing from this. That's interesting. Oh, no, it's in this HTTP Snoop capture metrics. This will run the handler and return a whole bunch of metrics. It's a really useful library because Go has this absolutely horrific interface for response writers where you're using like dynamic typing to figure out if I can close the response write or if I can stream from it and things. So this abstracts it all away, so I don't have to worry about it. And then we just tell Prometheus about the metrics we've observed, so the duration, the error code, and so on. Super simple. Again, single graph showing you the queries. Because I said the histogram was called request duration seconds, always use base units. Never use milliseconds or microseconds, always use seconds. I'm channeling my inner Brian. Then because it exposes a count, we can just rate that count, just differentiate it, and now we have the request rate. Okay, easy. If we want to do the same thing for errors, we use a regex to find all the time series for status codes that aren't 200x, 2xx. And we do the rate of that, and that's the rate of the errors coming to and from our service. And similarly, if we do the duration, if we do this, we can get the duration. So this is the 99th percentile. And this is a bit clunky. This is where the kind of abstraction in Prometheus leaks a little bit, because you have to expose the LE, which is the buckets of the histogram. But I'm going quickly, so I don't run out of time. I'm going to skip this demo, because you've seen the queries. So in most microservices systems, you have more than one service. Otherwise, they wouldn't be microservices. So normally, there's like a directed tree or graph of these services. And what the point I'm trying to make here is the red method can help you build dashboards for your entire kind of macro service. And what you do is you take the red method for the service at the top, plot that on a row, and then you do a breadth first walk of the next layer of services and plot each one on a row, and so on until you've built kind of all of your services out into a single dashboard. And now what that's helpful doing is when you get there's some errors coming into my front end, I just start at the top of the page and I look where the errors are introduced by going down the page. And this gives you the kind of hierarchical view of your services. A company called Vivid Cortex calls this hierarchical observability. And this is how you build it. You'd notice, again, I like to keep my dashboards relatively simple, like 2 things to a row, nice and uniform, because this is all about scaling like cognitive load. So we've got the latency on the left, We've got the QPS on the right, and this also shows error rates, but everything's well behaved today. One final bit of detail is on the latency graphs, so this is a zoom in of one of them, I have the 99th percentile and the 50th percentile, and everyone knows you should ignore averages and you should only plot percentiles, because there's no such thing as an average user. But something like a 99th percentile is telling you that 99% of your users are getting latencies less than this. That's really useful. However, because of the artifact of how this is implemented in Prometheus as a histogram with a set of buckets, if you get those buckets wrong, this can sometimes lie to you. And so what I really like to do is include an average and a 50th percentile, and as long as they're kind of close to each other, then I know I've got my buckets right. But if my average is higher than my 90th percentile, I've got my buckets wrong. And that's something I should really care about. What's more, there's a nice piece of maths around how latencies don't sum. If you've got a service that calls one service and then calls another service, like this service A, the parent service, can be experiencing high latency at the 99th percentile, and service B and C, the child services, can be experiencing low latency at the 99th percentile. And it's I don't know which one's wrong. But that's not true for averages. If you do that with averages, you'll definitely see which one is contributing to the average. Lots to read about this. The original slides from my talk at Weaveworks, the stuff from Vivid Cortex. Cindy, if people follow her on Twitter, they definitely should, because her stuff on logs and metrics is absolutely fantastic. She's a really good writer, and a really big fan of Prometheus and Grafana. And then Peter also writes really well, really good blog posts about logging and observability. So I'd recommend the last two. So, how long have I got? How am I doing? Okay? Next section? Yes, next section. 4 golden signals. So who here's heard of the 4 golden signals? I was expecting more. This is why a name is so important, right? 4 golden signals predates the red method. This is actually what the red method should have been. What it isn't is a sticker that you put on your mobile phone to increase signal reception, which is what you get if you Google for it. Now, the 4 golden signals is basically the red method. Time taken to resolve a request, well, that's the duration. Traffic, well, that's kind of requests. Errors is the same. And then this magic one is saturation. And the reason the red method doesn't include saturation is because I forgot about it. It should really be the reds method, I guess. But this comes from Google. This is Google's SRE book, which is online. It's a fantastic read if you want to understand more about the DevOps culture at Google. They talk about this. It predates the red method. It's just not as catchy. But yeah, saturation, how full your service is. What? How do I measure this? Well, it turns out there's an easy way of measuring this. It's quite cool. Basically, the idea is you can tell the number of CPU seconds a service is using, right? So we've shown you how to do that with the use method stuff. And with kube state metrics, which is a little job you run on your Kubernetes cluster that kind of scrapes the Kubernetes API and exports really interesting metadata about your jobs and services and pods and so on. You can compare the amount of CPU a service is using against its quota. How much should it be using, or how much is it allowed to use? And then that gives you a kind of, as a percentage between 1 and 0, it gives you how full your service is, or some proxy for how full your service is. And then this is kind of super useful because you could, for instance, build an alert on this. You could say, hey, this service over here has been using more than 100% of its quota, called its requests in Kubernetes, for more than an hour. Anyway, there you go. 4 golden signals. The Google SRE book. These are both things you must read. Summary. So we've been over the use method, the red method, and the 4 golden signals. We've talked about how the use method, which is utilization, saturation, and error rate, is really useful for resources and kind of a very infrastructure-focused view of your application. We've talked about the red method. So this is request rate, request errors, and request duration. You've got to prefix everything with request. And this is a super useful abstraction for dealing with microservices and for monitoring them. And this helps kind of reduce cognitive load and generally make your operational team scale. And then we talked about how the 4 golden signals is really what you should be doing, and saturation can be done kind of a proxy for it on Kubernetes. One of the little sayings I think someone said once is, you can think of the use method, the primary key, if there is such a thing, in your database is the host you're looking at. Whereas if you look at the red method, the primary key is the service. And it's really just 2 different views on the same system. So with that, thank you very much. And do we have time for questions, or? I think that's probably a no. We can take a couple of questions. Okay, any questions? I'll repeat them so we don't have to use a mic. No questions at all. Okay, well, that was good. Thank you very much, everyone.